So I'll just start out by talking a little bit about Koop because it's the example application that we'll be deploying onto the Kubernetes cluster that I have running. Koop is an open source project sponsored by Esri that allows you to connect third-party APIs and datasets into ArcGIS via the GeoServices REST specification, which is just the official term for the Esri feature services specification. So Koop is basically a translator. You teach it how to talk to a remote API. The example that I've taken some screenshots from, it talks to the Craigslist API to get apartments, and it talks to the Yelp API to get restaurants, and brings them together into an ArcGIS Online web map. So Koop is a really great, great thing to be containerized and packaged up because each one kind of talks to a different API. And so what I like to do is run a whole bunch of different Koops on a cluster. So I have one cluster and all of the Koops run in their own little containers so they don't bump into each other, or when one has a bug in it, it doesn't take down all the others. Docker is just a kind of a packaging framework for applications. For Linux-based applications, essentially you specify a series of commands that installs like your server or other tool inside this file system, and it's all packaged up. It's kind of meant to solve the works on my machine problem. If you have a Docker host somewhere, a Docker image, you can be pretty sure that it's going to run because everything that's needed from the operating system level is packaged up. But it's different than a VM because all Docker applications can share the Linux kernel. They don't have to package up the whole operating system. So containers have been used to get higher utilization on servers as well because you can pack a lot together because they're sharing portions of that file system. And another thing you should know about is the Docker Hub. That's an online container repository where you can get all kinds of images. Most Docker images start from an existing container that's up there on Docker Hub. Like the one in my example uses Node 6 as a starting point. So Koop is a Node application. I start from a container that has Node, and then I lay everything else on top of that. And I'll step through this Docker file a little bit later. And then what's Kubernetes? It is a container orchestration platform. It runs your whole cluster. You set up a Kubernetes cluster, which has the concept of masters, which are in charge of making sure that all of your containers are running in different places, and the networking is happening correctly, that persistent storage is lined up, and it has nodes. And nodes actually run the applications. They have all of the containers packed onto them. Kubernetes is a project that began life as Google's Borg project, something that kind of started making the news, I think as early as 5 or 10 years ago. And they have at Google a lot of experience in running containers. Kind of their whole set of services are running in containers across their platform. They open sourced Kubernetes, and now it's backed by Google and Microsoft, which is one of the reasons I think it's a really good bet to invest in Kubernetes for kind of application deployment because it's got those two big backers. And you see actually Google and through Google Container Engine and Microsoft Azure through Azure Container Services support Kubernetes as a first-class citizen. So you don't even have to necessarily worry about the cluster. I'll talk a little bit more about options in a minute, but the Kubernetes cluster is running etcd under the hood, which is just a simple key value store, but it's there to manage all of the state. So that's kind of where everything lives up in the cloud. And everything that goes into your cluster gets specified as YAML files. If you're not familiar with YAML, it's like JSON. It's a very similar structure, except it's more readable. So you're not specifying brackets and all that. I'll have examples of that throughout. So there are a number of good cluster options for Kubernetes. As I mentioned, there's Azure Container Services, which is Microsoft's platform, and they actually recently just hired the founder of Kubernetes, the guy who started the project at Google. His name is Brendan Burns. So I think you can feel pretty good about Microsoft's level of investment and support in Kubernetes running on their cloud platform. You've got Google Container Engine. Google created Kubernetes. They really want you to use this platform for deploying containers, and that's why they've open sourced it. But they support it really well through Google Container Engine, and will manage your master and all of your nodes, and you really just tell it what nodes you want to run. It'll handle upgrades and things like that. If you can use Google Cloud, you are really in good shape if you want to use Kubernetes. And then in AWS, it's a little bit choose your own adventure, but there is been a lot of investment into making it work. The tool that I've used to launch my cluster is called Kops, K-O-P-S, and the link to that there. And that works along with the AWS API and tools like Terraform to basically just stand up your cluster for you with auto scaling and all those things. So you don't have to go in there and manually turn on the different servers and make sure the networking is working and all those things, and security groups and all that. Kops will do that for you. There's also, Kubernetes has a getting started guide that has scripts on AWS if that's your poison. You can also deploy Kubernetes on-premise. I have not done that. I can't speak to how easy or hard that is. But I know it's built to work on-premise as well. And then there's something called Minikube, which is just if you want to play around with Kubernetes locally, you get a cluster running on your computer using Minikube. And all this stuff is open source from Kubernetes. It's all up on GitHub, so you can watch them developing it. It's moving at a really fast pace, which is something I like to see. So in my demo, I'm going to use a handful of Kubernetes components. What we're going to start with is a Node.js application and a Docker file, which just says how to install that Node.js application. And we're going to end up with a URL in the cloud. You're going to see how fast that happens. So that's why I really like it. But it's made up of a few different components. So in Kubernetes, the kind of base level component is a pod. And a pod is one or multiple containers that can be thought of as like a logical application, that they all work together. Most of the time, you'll just have a single container in that pod. So in this context, one pod would be one container running the Koop server. Then you have a replica set, which supervises your pods. So you say, I want a replica set that has 3, and Kubernetes will take that information and make sure that 3 of those pods are placed around your cluster where it makes sense according to resource utilization or any constraints that you've specified. And that's really what it means when I say orchestration. The cluster itself is placing the containers, making sure that they stay alive. These replica sets have things like liveness checks to make sure that your containers are healthy. And if they're not, the cluster itself will place other ones. If a node goes down, Kubernetes will rebalance all of your containers and pods so that all of the applications that you've specified through this YAML and all the configuration that you specified still lives on. It's all kind of abstracted away. You don't really think in terms of the server, you think in terms of the cluster and specifically the applications that you want to run. There's a deployment that I use, and that actually abstracts the replica sets and the pods. So the deployment is basically what container image do I want to run, how many of them, and then Kubernetes will create the replica sets and pods, and you don't have to mess with that in most cases. You just should think at the deployment level. And then there's a service. So a service basically puts a URL on a group of pods. So if you want to launch like a Postgres database in your cluster, and you want to reach it from any of your applications, you would have an internal service. So if you had a service called Postgres, any of the applications can reach Postgres using the DNS name Postgres. So, or if you had Redis or anything like that in your cluster, the service sets up DNS, but it also works externally. And all you have to do is tell Kubernetes that this service type is a load balancer, and it'll actually create a load balancer in the cloud. So it'll do it in Google Cloud, it'll do it in AWS, that it calls the AWS API for you, and at the end of the day, you have a URL to an AWS load balancer. Kubernetes does similar things with like persistent storage, so like EBS volumes, it'll provision those for you. It's another reason why I really like it. I can just think in terms of the application, what does it need? It needs a load balancer, it needs storage, it needs to connect to other services. I don't have to think about managing the DNS, managing the persistent storage, the load balancers. because Kubernetes does that for me. And then there's an ingress that I'll use. And that's actually optional, but I like to use ingress because I don't want to stand up 10 different load balancers. I want to have one load balancer that I can give a nice name to, and that'll just point via route to all the different Koops I have running. So I have /Craigslist, /Zillow, /Yelp. Those are all going through an ingress that just maps to services in Kubernetes. Okay, so I want to dive more into the specifics of this demo now and talk about the Docker file that specifies this Koop application. So it starts from node 6, and every Docker file starts with a from. Typically, you start with an operating system like Debian, Ubuntu, not CoreOS, but CentOS, whatever your flavor of Linux is. You start from there, and then you add layers on top of it. So line by line, this says start from node 6. So that's my baseline. I have node and npm and all that running, and it's already compiled, and I don't have to deal with that. I'm going to make a directory, so it's just a nice landing place for all my files. And then I'm going to add package.json, which specifies all the dependencies of a node application. And the reason I add that on its own is to leverage the Docker cache. Because my code changes a lot, but the dependencies don't. So if a line doesn't change, then Docker can use its cache and you can do builds really quickly. So there's a specific order to this. If I change anything in the code itself, it'll just copy that in and it'll happen really fast. It won't have to do npm install over again, which you can see is another one of these commands. So I add that package.json, and I always do that, add in my dependencies and install them before adding code in any of my Docker projects so I can iterate rapidly. And then I run npm install. And that's just installing all the dependencies, pulling them in from the npm website. That's just the node package manager. And then I add in all the code to that folder that I created. That's that add.line. And I expose a port that I can use, although that's actually an optional step. Finally, I set an entry point. And that entry point is just what should be run when you say run this container. So I say I want to run node, and I just give it the full path to the node. And I say the server file that I want it to run. So that actually looks like, switch over, oops. So you can see I just built a container, and you can see what the output looks like. We'll just scroll through it quickly. Sorry. So it's running each of these steps, and this is a fresh install. So it's running npm install and fetching all that stuff, adding the code. And now I can actually run this container and say just docker run.it means run an interactive. And it actually just booted up that server for me. Very, very simple at that point. And just to show you, just to hammer home the point about that, the caching, if I run build again, it's instant, because I didn't change anything. If I were to change a line of code in the server, JavaScript, it would be just as fast, because I've structured this so that I can leverage the cache. So if you're going to play around with Docker and you don't want to wait forever for builds, I strongly recommend you pay attention to that cache order and install your dependencies first. Cool. So I mentioned this deployment, and that's just a YAML file. The key things here are that I have specified the name of the container, or the image, I'm sorry, and that's dm Fenton /Koop Craigslist. That's what I've uploaded to Docker Hub. Docker Hub is free for open source and public projects, so I upload a ton of containers there. And Kubernetes can pull from that automatically just by specifying it there. I specify one environmental variable, and that's to tell it what port to run on, port 80. And then what port should be exposed on the container. So that's that container port. And then I specify a liveness probe. Liveness probes become really important, especially when you're updating your deployments. Because when you update a deployment, it's going to do it in a rolling fashion. it'll boot a new container from the the new image, so the new version, and it'll make sure that's working. It'll run that liveness check. So in this case, it's /status. And if that doesn't return a 200 code, HTTP 200, it'll actually abort the deployment. So you can have a mistake, and Kubernetes will protect you from that. It's also used, as I mentioned, to make sure that all the pods are healthy. If that starts failing, it'll reschedule the container onto another node or just restart it or something like that. And then there's a little bit of metadata, which is used usually if you're doing queries within Kubernetes. So show me all the things that match app Craigslist, for example. I wanted to see the service, the deployment, the replica sets, et cetera. But typically, you don't have to touch that too much. And then the number of replicas is specified. So when I launch this into the cluster, there are going to be 2 of these that run. The next file that's important here is the service. So what this does is says which port to expose. It targets the port 80, which is the one I had exposed on the container. If you remember that container port, the last example, that could have been open on 8080, but the port that's exposed to the outside and inside the cluster is called 80. And this is a node port, which means it's only going to be available internal. But if I change that to load balancer, then it would be external. I have it set as node port because I'm going to use my ingress to pass all that through because I don't want to set up a bunch of different load balancers in AWS. But inside the cluster, anything will be able to reach this server just by calling Craigslist. So if you were to go into a container on the cluster and be on the command line and do curl, which is just HTTP over the command line, curl Craigslist, you would be able to talk to that set of pods, that are load balanced behind this service. So with that, I'd like to actually go into the demo, and we're going to launch something onto this cluster. So what you're looking at here is the Kubernetes dashboard. Google's really improved this in the last just 6 months. And it keeps getting better and better, but you really get a good view of what's going on in your cluster. So I can look at my existing deployments, which is an Elasticsearch deployment, clients and masters. I can look at existing replication controllers, which you see all my other Koops that have been kind of launched in the old way. All of my individual pods that are running, how much memory they're using, et cetera. So great for getting information about the cluster, but I can also create kind of any one of these resources and tell the cluster what to do from here. Usually I use the command line, but GUIs are prettier, so I'll use this. So I'm just going to upload a YAML file, which I've got here, my koop.yaml. This is up on GitHub, so you can take a look at it as well. But I'll run upload. And that is going to create my deployment. And you can see I now have a Koop Craigslist deployment. And it's brought up this replica set. As I mentioned, that abstracted it. We dive down into this. We can now see that it has booted 2 pods, and they're running. That was instant, right? You saw that. That was instant. They're now running. But I still need to edit that ingress. So that's going to be my last step here, so I can get a URL. So I've got this main ingress, which is just an Nginx server that runs. There's a great how-to on how to set that up, and it's a little bit beyond the scope of this. But you can see what the rules look like. So Craigslist maps to the Koop Craigslist service name, which is it's the same server, but I just have it running already. I'm going to create another one. We can see /Yelp maps to service name Koop Yelp. So all the traffic to /Yelp will go to the Koop Yelp server. To Agal, Koop Agal, Socrata, Koop Socrata, TriMet, Koop TriMet. You get the idea. So I believe I'll just edit this. Let's change Koop Craigslist just to point to Craigslist. And we'll change this to, leave it like that. Cool. So I'll now have a path in, and I go to adapters.kubernetes.com, just maps to that ingress. So that's why I use it, so that I have that one friendly name, then all of my different Koop providers, which just are translators for different APIs, just live under there. So you can see this is now giving me a feature server specification, and I can take this and go into ArcGIS Online, create a new web map. And I can now add this layer from the web, and it's going to give me all of the apartments in Washington, D.C. At least it should, anyways. Well, live demos for you. But you can see that the API is running. I'm able to query. This isn't really a Koop demo. My Koop demo is on Thursday. It'll all be working by then, I promise. But so there's the server running. Maybe it's loaded by now, maybe not. That's unfortunate. But you can see that the API is live there under that route. I'm gonna make a change now just so you can see also how it'll give you a AWS load balancer and how easy it is to make changes to your cluster on the fly. Usually I do everything with files checked into Git, but for this demo, I will just go through the UI here. So I can just edit this. Actually, excuse me, I need to edit the service. In my Craigslist service. So where it's type node port, change this to load balancer. And then give it a second because it's going to call the AWS API. And you see I now have an external endpoint for this server. So I can take this, and sometimes it takes a second, so it might not be working right away, but I can take this and just replace it. So I have a new load balancer. Yeah, that'll take a second for DNS to kick in, but the idea is that just by changing that to load balancer, I now have an external AWS load balancer that's directing all the traffic in. If I wanted to increase the number of replicas, so I'll go into my deployment, and I will edit this. I will change replicas to 4. Go and look at that replica set, and you can see that it's already placed 2 additional, and I've scaled up. There's all sorts of auto scaling that you can do, but that's also kind of beyond the scope of this this demo. But that load balancer is going to direct traffic on all of them, so it's very easy for me to launch kind of resilient little micro apps, basically, just by saying I want to run 2 at a time. They're not going to step on any of the others. They do a really good job of sharing resources on the cluster. I basically have enough resources to launch however many little apps that I need. Last thing I want to do is show you updating this. So if you want to update, the nice thing to do is add just add a new tag. So I'm just going to run a build here, and I'm just going to give it just a new tag that I'll be able to specify. So that colon just specifies the image tag. And it's going to use that cache again, which is nice. But if I want to now update this application, I just go back in to my deployment, edit, and where the image is Koop Craigslist by default to latest, I'll say, what do I call it? Demo, yeah. So I can update that. And so you can see the status here. So it's doing this rolling update for me that I talked about. It's booting 1 at a time, making sure that the status checks pass, and then taking 1 out at a time. There's different strategies that you can specify, but the default is really solid. And so this is how I launch all of my little demo applications. I just specify the Docker file, the deployment, the service, put it in the cloud on my Kubernetes cluster, and then I edit the ingress. And that's it. So with that, are there any questions?
So can you compare and contrast why you went with Kubernetes instead of Docker Compose or Swarm? I don't know if, yeah.
Um, the reason I use Kubernetes is that it's supported by Google and Microsoft. So you get some really big horses behind it. Docker's had some issues specifically with stability. And they're moving really quickly, which is good for Docker, but it can be kind of bad for others. And they've had issues with stability. They also don't come from the experience that Google had in building Borg to come out with Kubernetes. So it's really battle tested. You've also got that first class support on Azure and Google Container Engine. So that's why I use it. I think that that's going to be the one that wins out in the end. Mesosphere and DCOS are really interesting too. But I think that personally, I think that Kubernetes is going to win out. So and it works really nicely. So that's why I've invested my time in it. But others are good options. I personally have less experience with those. Yeah. You had a question, right?
Yeah, more like how did you come up with? Why did you come up with playing with that? Like, was there any business need behind that?
So I work for an R&D center, the Washington D.C. R&D Center, and so we're given a lot of latitude to experiment with new technologies, and that's kind of why I tried it out. I wanted to do it, and it makes sense for me because I deploy a lot of little applications. So just interest.
How difficult slash easy was it getting started and set up with Kubernetes?
My first iteration was fairly difficult using the like older guides, and that was like 2 years ago. So using the Koop up scripts and kind of managing that cluster. I've gone through, this is my fourth one now. The fourth time was the easiest, not just because I had the experience, but because of the COPS tool that was built. So Google's really invested in the operations aspect and built this tool that I can say, I want to be on AWS. I want my nodes to be this size, my masters to be this size, and it actually did the distributed masters in different availability zones. It was actually really easy to get that set up. And then the guides that they have are really awesome. So if you look at that deployment is like, what? So it's 26 lines of YAML, and most of that is just boilerplate off of the example. So once I hit the learning curve of getting the cluster right, it's really easy to use the cluster and use the command line and those things. Yeah.
So does Koop work against non-REST endpoints? Like, let's say if you have a database or say a Java-based distributed store or something, can you write a provider for that?
Absolutely, yeah. So it's a plugin. Koop is very extensible. So you just write a plugin, and the node can do a lot of those things. You can either kind of shell out to the command line and call that Java process, or you can do a database. I talked to a guy yesterday who had deployed Koop inside an Electron app to talk to a Spatialite database. So yeah, absolutely. As long as there is some API that's programmatically accessible, then you can build a provider for that. And I'll talk about that Thursday at 9. Koop, for the most cases, read. So usually you have a third-party API. That's where the data lives. You don't do write. But there's no reason that you couldn't do write. And one of the ways I've been interested in expanding Koop, specifically the open source implementation of the geoservices spec, is to add, like, apply edits and things like that. And then you would write the logic in your provider to make those edits. And so it would just translate the right part as well. But most of the time, people are doing read stuff. Yeah.
So have you tried deploying Kubernetes in-house with the multiple machines? Is there any difference between in-house deployment of Kubernetes versus the cloud?
There's definitely going to be differences in how you install it, but the API will be the same. So you have to handle your networking. Yeah. The biggest one is going to be you're going to lose that friendly provisioning of persistent storage and load balancers because those rely on APIs, from AWS and Azure, to call that and set that up for you. That typically doesn't exist in on-premises environments. Maybe with VMware, things like that, but or vSphere, I mean. But yeah, the API itself will be the same. It'll lose maybe some of the functionality, and of course, setting it up is completely different animal. Yeah. All right. Well, thank you all very much for coming out.